Finding the domain of a rational function and simplifying rational expressions. There are 4 topics we want to discuss in this lesson. First, vocabulary. Second, simplifying rational expressions. Third, be able to find the domain of a rational function. Fourth, know the connection between the vertical asymptote of a graph and the domain of that graph. A rational function. A rational function is a function whose equation can be put into the form f of x equals p of x over q of x, where p of x and q of x are polynomials and q of x is not 0. Simplifying a rational expression. Simplifying a rational expression is writing an expression in its lowest terms or in its simplest form. And the 2 things to keep in mind when simplifying rational expressions. First of all, completely factor the numerator and denominator. And the second, divide out factors that are in common with both the numerator and the denominator. Factors. Constants or variables that can be divided out of a term. Evaluating rational expressions. To evaluate rational expressions for a particular value, you substitute the replacement value or values into the rational expression and then simplify your results. So for example, if y equals -2, and I have an expression y minus 2 divided by -5 plus y, I would substitute -2 in for this y and in for this y, and then simplify my results. Now, finding where a function is undefined. A rational function is undefined when the denominator is equal to 0. If the denominator can never equal 0, the rational function will never be undefined. So for example, if I'm trying to figure out where this function is undefined, I take my denominator and set it equal to 0. And then I solve for x. So this rational function is undefined when x equals 3. For the next function, you set your denominator equal to 0. That's how you can tell where it's undefined. And then this is the difference of squares. So that should equal x plus 2 times x minus 2. Which means x can equal -2 or +2. In this case, there's not a value for x that will make your denominator 0. So this function is not going to ever be undefined. So let's simplify some expressions. First, in this case, 3 plus x divided by x plus 3. Well, I can use a commutative property to rearrange x plus 3 to 3 plus x, or my numerator 3 plus x to x plus 3. In doing that, I have the same expression in the numerator and denominator, which means that equals 1. In this case, 9 minus x divided by x minus 9. Well, there's a property. This is not the commutative property. But if I change my numerator to x minus 9, it will be equal to the opposite. So actually, x minus 9 equals negative of 9 minus x. So pay attention. For subtraction, if your terms move, your answer is the opposite. But for addition, 3 plus x equals x plus 3. But for subtraction, 9 minus x does not equal x minus 9. 9 minus x equals the negative of x minus 9. And then these can be reduced to 1, and I'm left with negative 1. In this case, remember, the first thing you want to do is factor if you can. So I can factor my denominator to x plus 2 times x minus 2. Then I can reduce x plus 2 and x plus 2 to 1. And I'm left with 1 over x plus 2. In this case, I want to factor first. I can factor a monomial of 3 out of my numerator and a monomial of 4 out of my denominator. Where there's nothing left to simplify in this expression. So it cannot be simplified. Please pause the video and try to simplify this expression. I will give you a hint. Factor your denominator first. Okay, so in factoring our denominator, if we did product sum, what can we multiply together to get negative 45? Add together to get negative 4? Well, that would be negative 9 and positive 5. So x minus 9, x plus 5. And then my x plus 5 in my numerator and my x plus 5 in my denominator reduced to 1. And I'm left with 1 over x minus 9. In this case, we have to use product sum to factor the numerator and product sum to factor the denominator. Remember, because my leading coefficient is not 1, my product will be 3x squared times 2 for my numerator, and my product for my denominator will be 3x squared times 4. So please take a moment to pause the video and factor the numerator and denominator and simplify. Okay. So if I factor my numerator, I end up with this. When I factor my denominator, I end up with this. And if you notice, I have 3x plus 1 in my numerator and 3x plus 1 in my denominator. That reduces to 1. So my simplified answer is x plus 2 over x plus 4. In this case, because I have 4 terms in my numerator, remember we want to factor our numerator and factor our denominator. But because I have 4 terms in my numerator, I want to factor by grouping. And then notice, what can I factor out of the x squared term and the xy term? And then also, what can I factor out of 2x and 2y? And so remember our factors. Once we have this, the stuff inside the parentheses should always be the same, and that will be one factor. The stuff outside our parentheses is our other factor. And now I can reduce x plus 2 divided by x plus 2 to 1. And I'm left with just x plus y. Let's factor again. Please pause the video and try to factor this on your own. Okay. So to factor our numerator and factoring our denominator, we get this. And then x plus 3 in my numerator and x plus 3 in my denominator will be simplified to 1. So I'm left with 2 over x minus 3. Do the same in the next problem. Please pause the video and try to factor the numerator, factor the denominator, and then simplify your result. Okay. The first thing we want to do is, because I have a multiple of 2 for each term, I can factor a 2 out of each one of these terms. I can also factor a 2 out of each one of the terms in my denominator. And so I can reduce 2 divided by 2 to 1. I can reduce x minus 5 over x minus 5 to 1. And so I'm left with x plus 2 over x plus 5. Please make sure that you complete the homework in my math lab on lesson 7.1. Thank you.